Good morning, students. Today we start with the next chapter of geometry, that is coordinate geometry. In this video, we are going to study about the basics of coordinate geometry and distance formula. Let's begin. Let's recall the distance between any two points on the number line. We know how to find the distance between any two points on a number line. If the coordinate of point P, Q and R are -1, -5 and -4 and 4 respectively, then find the distance between PQ and QR. Okay, so here what we have been given. Now here distance between any two points on the number line, right? Now we have been given the 2 points over here. We know how to find the distance between any 2 points on the number line. Okay. Now the coordinate of point P, Q and R is given to us and the number line is given to us. Here it is 0, 1, 2, 3 and 4. Here it is -1, -2, -3, -4 and -5. Okay. This is point Q. This is point P and this is point R. Now distance between PQ. Whenever we have to find the distance between any two points, then we subtract the coordinate smaller coordinate from a bigger coordinate. Okay. Now here x2 is bigger as compared to x1. So distance between AB is x2 minus x1. Right. Now here distance between PQ will be -1 minus of -5, as -1 is greater than -5. Okay, so it will be -1 plus 5, that is equal to 4. Now distance between QR, coordinate of R is 4 and coordinate of P is -5. So it will be 4 minus of -5. So that is equal to 4 plus 5, that will be equal to 9. Right. So in this way we find the distance between the 2 points on the number line. Now the same concept we are going to use to find the distance between 2 points on the same axis in xy plane. Okay. Before that, we'll understand what is Cartesian system. Now Cartesian system, when I'm talking about, so the two lines intersect each other. Now this concept is already done. I'm just giving a revision. Okay, so this is O. Here we move, it is all positive. This side we move, it's all negative. It is x dash x axis. Okay. Similarly, when we move upside, all are positive. As we move downside, all are negative. And this axis, the standing axis, is known as y-axis. It is represented by y dash. Okay. Now, as I told you that these are all positive one, these are negative. Here we go down, it is negative. As we move up, it is positive, right? Okay. So this two lines divides the full plane into 4 parts. The first one is known as first quadrant, as it is moving anti-clockwise. So second will come here. Okay. So this is second quadrant. This one is third quadrant and this one is fourth quadrant. Okay. Now all the points over here is represented will have the positive sign. Okay. X will be positive, y will be positive. Here x will be negative, y will be positive. Here it will be negative, negative. Here it will be positive, negative. Okay. Now suppose you have to represent any of the point on the number line in the Cartesian system. Okay. Suppose this is point A. Now wherever, if you draw a perpendicular from the point on the x-axis, wherever it is intersecting, that will be x coordinate, and if from y-axis I'll be drawing a perpendicular, and wherever it is intersecting, it will be representing the y coordinate. Okay, or you can say AB is parallel to y axis, so wherever the point is here, okay, so this is y, and here it is parallel to x axis, so it is representing x coordinate. Okay, now here it will be x1 y1. Okay, this part is known as abscissa. Now x coordinate is known as abscissa, and y coordinate is known as ordinate. Okay, so whenever we are writing, suppose a 4 5, okay, so this 4 is x coordinate and 5 is y coordinate. Okay, so 4 is known as abscissa and 5 is known as ordinate. This part is known as ordered pair. Okay, now we move on to the next part, that is to find the distance between any two points on the number line. So first we'll go on the point which is represented on x-axis, which is on x-axis. Okay, so for that we'll need a Cartesian system. Okay, now two lines are intersecting, so that will be point O wherever it is intersecting. Here is point A, this point is representing point A. Now the uh, coordinates of point A are x1 and 0. Okay, and here it is representing point B. Coordinate of that point is x2 and 0. Now what do you observe over here? That whenever the points are on the x-axis, the y coordinate is 0. Okay, now the distance between any two points on the x-axis will be x2 minus x1. Okay, as x2 is bigger than x1, so distance between AB is x2 minus x1. Okay, now the next part, now to find the distance between two points on y-axis, so we need a Cartesian system. So this is what is the Cartesian system. Okay, and here the sleeping line or the horizontal line is known as x dash x, and vertical line or standing line is known as y dash. Okay, here it is point P and here is point Q. Now point P is representing 0 y1 and point Q is representing 0 y2. As you move above the x-axis, the value goes on increasing, so y2 is greater than y1. Okay, as y2 is greater than y1, so distance between point PQ is given by y2 minus y1. I hope I'm clear. Now we move on to the next part, that is to find the distance between two points if the segment joining these 2 points are parallel to any of the axes in xy plane. So here now what you observe is very first figure. Here is the Cartesian system. Fine. This is y dash. This is x dash x. Okay. Now if I draw a line parallel to which axis? It is parallel to x axis, right? Now if I draw a perpendicular over here, so wherever the points are intersecting, right, so that will represent the x coordinate. Okay. Now in the figure, AB is parallel to x-axis. Y coordinate of point A and B are equal. Okay. Now here, if I have to find out the coordinate of point A, it will be x2, x1, y1. Coordinate of point B is x2, y1. Okay. Why? Because it is representing the same point. If I draw a perpendicular, it will represent the same point. Okay. Therefore, whenever a line is parallel to x-axis, its y coordinate is equal. Okay. Now, whichever point, if I take on that particular segment, its y coordinate will be equal, but x coordinate goes on changing. Okay. So, draw a line segment parallel to perpendicular to x axis. So AL is perpendicular to x axis. Similarly, BM is perpendicular to x axis. Okay, so I have got a rectangle over there. Now here AB is equal to LM. Fine, as AB is equal to LM, but LM represents x2 minus x1. So what will be AB? AB will also represent x2 minus x1. Now the line segment parallel to y-axis. So it will be same way. Okay, same way, parallel to x-axis, sorry, y-axis. So this is PQ. It is parallel to y-axis. If I have to draw a perpendicular over here. Okay, so PR is perpendicular to y-axis and SQ is perpendicular to y-axis. Now, which coordinate will be equal of P and Q? Naturally, x coordinate will be equal. So it is x1, y2, and q, it is x1, y1. Right? Similarly, coordinate of S will be 0, y1, and coordinate of R will be 0, y2. Now, which coordinate is same over here of PQ? X coordinate is same. Right? What is changing? Y coordinate is changing. Okay, when I draw the perpendicular, I get a rectangle. That rectangle is rectangle PQRS, in which PQ is equal to RS. So distance of RS is y2 minus y1. Therefore, distance of PQ will also be y2 minus y1. I hope I'm clear. Now we move on to the next part. Now we move on to the next part, in which we are going to perform an activity. So in this, we have been given a Cartesian system. Okay, I'll just draw a rough figure. Fine. And here somewhere is a triangle drawn, which is a right angle triangle, right? And we are supposed to find the distance between AC. Okay, now here, as it is a right angle triangle, ABC is a right angle triangle, so we can apply the Pythagoras theorem over there. So AB square plus BC square is equal to AC square. Now to find the distance, what we have to do? We have to first find the coordinate of B to find the length of AB and BC. Okay, now CB is parallel to x-axis. CB is parallel to x-axis. So y coordinate of point B is 2 and BA is parallel to y-axis. So x coordinate is 2. Okay, So AB will be equal to 2, 3 minus 2, that is equal to 1, and BC is equal to 2 minus of minus 2, that is equal to 4. So what is AC square then? It will be AB square plus BC square. So AB is 4, so square of that is 16, and BC is 4, so it will be 16, and AB is 1, so it is 1. So distance between AC square is 16 plus 1, that is equal to 17. Now when we take the square root, we get AC is equal to under root 17. So the same concept we are going to use in the next term, what we are going to learn, that is distance formula. Now distance formula, when I'm talking about, in the figure, A is representing a coordinate x1, y1, B is representing x2, y2. Now are the points in an xy plane. From point B, draw the perpendicular BP, and from on x-axis. Similarly, from point A, draw perpendicular AD on segment BP, as BP is parallel to y-axis. Now, x coordinate of point D is x2. Okay, x coordinate of point D is x2, and AD is parallel to y-axis. Y coordinate of point D is y1. So AD is equal to x2 minus x1, and BD is equal to y2 minus y1. AB square is equal to AD square plus BD square, that is equal to x2 minus x1 whole square plus y2 minus y1 whole square. So here when I take the square root of it, it will be AB is equal to under root x2 minus x1 whole square plus y2 minus y1 whole square. This is what is distance formula. Okay, this concept we are going to use to solve the problems which is given in practice set 5.1.